is a little bit different than the older ones that we have. Sometimes later on I will show our old protocol, but that protocol is now the protocol we use at all German plants. I think I know it from Seebach and Pfronten. So they are now looking, the description is a little bit more than the old one. For example, I look for an old one. It's done my. Deutsch. Was it? Heute. Und die Scheißdinger. Archiv vielleicht.
Scheißdinger.
Da war doch mal ein alt. Blockportal des Schalters. So if you look at that one, that's from a portal machine, but anyway, that's an old example. So if we compare the old one, there's the description. Yeah, machine must be installed in closed hall and some stuff. Here we say temperature and some hints are in, but when we look to the measurements, yeah, das schaut so anders aus. Yeah, if we compare it, also the old dual block was in this older version, the first measurement of measurement here in the plant is the runout and the center brush concentricity. So in that case we have no table, we have pellets, but anyway, so the second measurement is the straightness of clamping surface, also the pellet. That means in X and in Y. This wire is clamped. That means parallelism, rotary motion, and so the description was that the old protocols, any types, yeah, looks like here the same. It was not so much description in, but it was shown with a good sketch, so that you see how to measure it from 1 to 2 position. That way we have a point measurement or something here also. But if I switch over to the new one, the dual block, so here is also described test number 1, 2, 3, 4, and there the big difference is the test number for the runout is not the first measurement. So, but I told you before, if you have to do a geometric check after collision or deviation or reclamation from the customer side, you have to look out. The first thing is, I told you the table is the basic, so you have to do the runout. This is very important. So in that case, it looked, checking the run out from the spindle. One, der kommt weiter unter, gell? Yeah, but I will explain step by step here this protocol. So first you see the number of the tests and how to do it. In that case, checking the squareness between z-axis and x-axis motion. So that's 3 measurements. That are our cross angle, and you can also remind to our coordination cross that you have the squareness and the squareness of that axis in that way. Then there is also test number 4 that will be accompanied to check an axial slip of the spindle. So that measurement normally, I think nobody does it outside. But I know also from my experience, you can have problems with axial slip or axial gap of the spindle or the bearings. Then you have to test it. So now you see there is some tests are underlined, and that means underlined tests are necessary by installation. So I think here is it. So there is the sentence in the protocol. Underlined test numbers indicate the test items to do them at manufacturer shop floor and at customer shop floor. So that should be that measurements here. We call it 5, 7, 8, 13, and not more. That are the first, maybe, for installation or commissioning. So that have to do for commissioning. I have here an example for a commissioning. This is also an older protocol normally that are, in that case, 5 measurements to do it for machine installation commissioning. I think there was some guys, they do the commissioning also. Yeah, I think so. So you see, we have a lot of protocols. This is the German one. Also. But to go to the actually protocols that we have, I think we have it 4 years now, I think, 3, 4 years. We have to use this new protocols. And the difference is we have, more description of that measurement. So if you see that protocol, you have also description, but not so deep enough. And if we have the new protocol, there will be a deeper, for understandable, deeper sentences. And if we continue measurements, you see there we have the coordinations values where that measurements will be done at the machine. That means from reference point, we have x 400 millimeters position, y-axis minus 525 millimeters position, and z-axis minus 100 and minus 600. So that are the coordinates. This is the big difference we have at the old protocol, there are no coordinates be described. We have some description about the lengths, how to do, or the angles, but we have not reference positions. Yeah. So, and also here, number 2, that's in my way. Yeah, if you come to a customer, you take out this test chart and you see, first I have to measure the cross angle, but okay, I will do. Yeah, that's a measuring fault, because I told you that the basic is the table, and please remind every time collision or deviation or reclamation or something, take the basic and measure first the table run out. Yeah, center brush, I think it's not a big deal or not the important thing. The run out is the important first measurement, how to do or to check a machine geometry after collision, crash or deviation. So second measurement, that's okay. That's also at the old protocols, there is the cross angle measurement. So that means condition y to x, and also z to y, that we can find out the derivation. And you see yz level, that's that measurement I told you, or I show you. We have 2 tolerances here for the machine that also depends on the order of the customer. Maybe you have a half tolerance machine or a mu precision. So then we have different tolerances. So in that case, we have an ISO tolerance. That means that there's a Europe norm, and they are meaning we have 20 microns tolerance of 500 millimeters measurement sequence. But the second field we see, the DMG Mori tolerance for that machine, has to be inside 16 micrometers, also by 500 millimeters length. So that means if you have you measure out 18 microns, you have an ISO tolerance, that's okay, but not okay for this customer delivered machine. So you have to be, in that case, inside these 16 microns. So and so on. The next measurements were y to x, also a cross angle measurement. We see the measurement A. That means you have to align the T-angle or your square or your frame, whatever you have, in X, and then you have to measure it with in these coordinates. Always you have to also look on the coordinates, and then you measure out in the y-axis. Then also see ISO tolerance, DMG Mori tolerance, and you have to be inside 16 microns. So that now the measurement also, I think, I don't know, is it in the old one? I think it was in the, You see, there was later on that measurement axial rest of spindle, or this slip or spindle gap, was in the old protocols around 9 or 10. With the new one, we have it on measurement 4. So I said that's not the big thing you have to know, but or you have to figure out at the machine crash or something. So, but also for that we have a tolerance. So milling spindle has to be under ISO tolerance not more than 5 microns. DMG Mori tolerance said not more than 4 microns. So in that case, the coordinates are complete senseless. You don't need it. You can do it in any position you would like to measure it out. Checking run out of the spindle taper. Yeah, we do it with the test manual, you see, or I showed. So there is normally to do it with this test sheet. If you mostly, yeah, you have to do eight measurements for the complete spindle run out, and you calculate it also. Here also is not very important to use that coordinates. They are only written down, but you know, spindle nose. Here at that case, we have 10 microns. Spindle nose means he had the test manual 20 millimeters from the measurement sequence from the spindle nose. And therefore we have 10 microns ISO tolerance and 8 microns DMG Mori tolerance. And now you see that measurement was underlined, and also you have to measure it in the factory, and then you have a field to measure it at the customer or to write it down after commissioning. Same for the distance. Yeah. Mori tolerance in that way, 16 microns at 300 millimeters. So here we have a process, is the flatness of the table surface. But I'm not sure is this, I think that is to do with an laser equipment or an nivelator, or what's it called? Yeah, I think that's normally laser measurement. Yeah, there is a little bit hint that also, yeah, need to know for every mechanical, I think. So a flatness of a table, it should not be complete flat like a mirror, or a surface like a complete flat. So normally we have to use that it's a little bit convex, or not complete straight. Can you imagine how it should be not complete straight?
Why it shouldn't be flat?
Sorry again?
You're asking why the tables should not be flat?
Yeah.
I believe it's to accommodate the weight of a part sitting on there. Kind of want it to be cupped outwards so that when you set something on it, it kind of flattens out to where it should be.
Yes, correct. And also, yeah, if you have a flat to flat workpiece and flat table, yeah, it's one thing that we have thing that we called it sucks on the table in that way. So therefore, no table here at the company is to 100% lead. But here also it will be measured out with laser points. So in the past there was not the big deal, but now we have some new equipment since I think 2 years. Maybe some of you heard about that means. Or another question: do anyone know the 3D quickset equipment that we deliver with the machine?
Yes.
Yeah. And therefore we have a new equipment that means VCS, that means volume compensation equipment, and that has a big influence of kinematic in the volume of the machine. So that's I think when we look at that measurement in the past, in the protocols you didn't find that, but in the new measurements or protocols we see some laser or level measurements that you, if you see it now, or if I explain it, then you know their manufacturer or here at the Deckelmau plant, they use some points and measure out something flatness or range for later on, or correct something to have good values for kinematics. So I think that's the reason why they use it now at the protocol. But in the past, we didn't have that measurements.
So in that last one, is it asking you to use a gauge block instead in place of the laser? Like it's wanting you to go, like measure a block in each of those spots? Is that what it's kind of asking, or?
I think it will be done with some. I'm not sure. Yeah, that is a point measurement, but I think they measured not of a gauge block. I think they will do it on the surface directly. Gauge block here. It has described as a gauge block here. You're right.
There's only like 4 fields, though. I don't know if they want you to put the whole range or.
Yeah.
I don't know.
Me too. So sometimes, but that's a good hint. So I will ask tomorrow some measurement guys here on the plant. So because I'm also not 100% sure how is this. So maybe I can answer it tomorrow.
Alright.
So yeah, this Robbie Morgan. Yeah. Here at measurement number 7 is the parallelism between the table surface in the 4 rotary positions at 90 degrees from each other and the x-axis motion. Yeah. So normally set to 0, go to the legs. That means here coordination values x 70 and 730. So that's the movement. also I think it's a little bit, I don't know why they use two tolerance in their protocol. So normally they are the machine manufacturer, and I don't know why they say, okay, we have an ISO tolerance, but we build up two tolerances, but only this tolerance, DMG Mori tolerance, is what a customer accept, I think, because he buy the machine by DMG Mori, and yeah, maybe some export thing that they have to do it now. Maybe the whole world had so many rules. They has not to be understood. Yeah. Okay, let's continue. Measurement 8. Alignment between table surface and also rotary positions at 90 degrees. We have 20 microns, and I think we have the 20 microns because we go for a way of 660 millimeters. So when we saw before the 16 microns, that was around 500 millimeters. That's different in that way. Squareness between table surface and 4 rotations positioned by 90 degrees. Yeah, you see T bracket or T angle or whatever we call it. Also a measurement. And the same thing we will do tomorrow, yeah, with practice that we see it on the naked machine here by side. One question, did you know these protocols or did you work with that?
The ones that we have look a little bit different, but it goes over basically the same thing.
Ones that you use for commissioning, or?
Yes, we use the same ones that's delivered with the machine.
Yeah. Yeah. So that's okay. If you have a little experience of that, and I think in this training, we didn't have to go in every measurement. That makes not the big sense. Big sense is that you understand how to check or to find out a deviation after a collision or something, or if the customer recommends he had a deviation in workpieces. So where we start to find out some deviation here at the machine. Kommt es noch, oder? Du und da was? Das Protokoll, wo du da hast. Ja, das ist jetzt. Das ist wohl laser, oder? Yeah. There also a description of the laser table, and then there are measuring results. So normally, I think if you have to measure with a laser, you have to have another training and to have to be trained to laser measurement. So, was hast du da für ein Protokoll? Okay. Ja, das macht nichts. Machen wir da weiter. Yeah, I have also here described, we call it a ball bar test. Maybe you know this. That will be one side is in the spindle, one side is on the table, and then we have to measure the round out of the table, and also with that one we can compensate the roundness of the table run out.
You need a whole like setup to do this though, right? Like a whole yeah, ball bar system.
Yeah, that looks like here.
Alright.
So that
Yeah.
yeah. There is also the deviation to the axis like xy, yz, and xz planes. So and therefore also we have tolerance. The ISO tolerance at 30 microns, the DMG Mori tolerance at 10 microns. So Thomas measuring always clockwise from a zero starting point and counterwise also to check, to find out some gap or ball screws, gap, linear guides, deviations or worn out or something. For that is ball bar test. Very good. Yeah, that normally that's we accept that's the part that we will be milled out by the factory, and to have tolerances, perpendicularity, parallelism, center holes. So that is in that way described. So that's normally that will be done at machines, or I think I didn't know it. Did they do this on every machine? I think not. So Abnahmeteil. So I think now they will do that workpiece to pre-acceptance from the machine at the delivery, and there are the tolerances here described of the centers of the brushes, of the holes, and also that part will be milled and drilled on every machine for delivery. So that's the new protocol.